Okay, so this is example 3, and again, we're determining a value of an annuity. But now the annuity, the interest is compounded n times per year, as opposed to once a year. So if you look on, so this is page 527. So on page 526, you'll see a yellow box, right? Which you should have written down already, which is the value of an annuity, interest compounded n times per year. So that is a formula that we're going to be using. So again, it's really a plug and chug process. Again, you're going to have the formulas on your exam. You just have to know what the values mean, and of course what it's asking for. So at the age of 25, right, you decide I'm going to save for retirement, right? So you want to put in, $200 at the end of each month into an IRA, right, that pays 7.5% compounded monthly. Notice you're younger, so you're probably not putting in as much money because, you're probably making a good amount, but when you're 35, you're probably making a little bit more or a lot more. And you're 25, you're having fun going out, and so you're probably spending money on other things. So you decide, okay, only $200, which is still going to be powerful. So again, how much, right? What's the value of your annuity, right? Your IRA, your individual retirement account, when you're 65, and then again, the interest. Again, same idea. The only difference, again, is that, okay, so obviously new formula, right? There's your P, there's your R, there's your N to the NT, over, let's see, I want to get my arrow. Okay, actually I want to get the dot. Okay, so I want you to notice that, okay, we have P, right, R, we have N to the NT. Okay, so the time, now you're 25 years old and you're going to retire, your plan is to retire at 65. That is a 40-year difference, okay? That's why your T, right, this guy, T is 40, right? Because 65 minus 25 is 40. So that's where they're getting the 40 from. And everything else, again, just plug and chug. Right, use your calculator right here, right? All this, again, work for your test. This is partial credit. I want to see you punch in this value because it's finite, all the way raised to the 480 power, minus 1, and then times 200. And of course, right, you're going to generate a value. So $604,000, well, 604,765. So after 4 years, right, this is what we have. And then again, on your, so for your interest, right, this is the value of the annuity, but you started at $200, right? But $200 every what? Well, if we just go back up, right, read what we had. So $200 at the end of each month. Well, there's 12 months in a year. So, whoops. So here, that's what we have, 12. So 200 times 12. And let's see, get my... Okay, so we have, right, we have our, whoops, let me get the arrow. Okay, here's the value of the IRA, right, minus your total deposits. $200 times 12 months, right, and times 40 because it's after 40 years, right, from 25 to 65. So if you would save $200 every month for 40 years in a shoebox, they would be $96,000, which again is not too bad. However, with the IRA, I mean, that's a nice chunk of change there. So you find the difference, and the interest, right, not too shabby, 508, 500, basically $500,000. And I believe that is that's it for this example.